Just wondering, do you build your pipe stress models from scratch? Just wondering, have you ever tried to import piping geometry to your stress program and been dissatisfied with the result? Afterward, wishing you had built the model from scratch, probably in less time than it took cleaning up the import. Have you ever considered how much time would you save? How much more would you enjoy your job if you could truly import your 3D piping geometry from your design package into your pipe stress program, and the result was indistinguishable from your hand-built model? Have you ever wondered what the word for pipe was in German? Okay, probably not. ROHR is German for pipe. In this video, I am now going to show you how to import 3D piping geometry from your design program into the pipe stress program ROHR2 via a neutral interface, in this case the piping component file, or PCF. In ROHR2, click File Open or simply click on the Open Project button. On the File Type pull-down, you will notice the many neutral file formats that ROHR2 can read, such as Caesar2, Intergraph, Autoplant, but for this demonstration, we will choose PCF. ROHR2 has the ability to open more than one PCF file concurrently. Typically, each pipeline name's geometry is stored in one PCF file. After choosing all the files wanted in the analysis, they are opened into a mechanically contiguous model. At this point, we are already in a position to run the analysis. I will turn off some of the on-screen information for this portion of the presentation. Before we run the analysis, I will show you the 4 lines that were imported. They are arbitrarily called Pipe 1, with this spring on the dummy leg and some supports, this one with a guide. Pipe 2, tying into the T. Pipe 3, going up to the cooler. And Pipe 4, a branch with a PSV line. Again, these would typically be your line numbers. Let's go ahead and run the analysis. We select all load cases and OK. Since we haven't saved the job yet, ROHR2 prompts us to save this job. Now ROHR2 is saving the job and running the analysis and all the load cases. The analysis is now run. There's 0 errors, 0 warnings. ROHR2 did a spring design for the 2 springs underneath the dummy legs, ran the dead load and operation cases, and the whole stress analysis. We can view the results of the analysis here. For example, if we want to see the pipe centerline's displacement in the operating condition, it is indicated by the red line, or the stresses are indicated by these colors. In addition to the line numbers being retained after the import, other information such as support tags is also retained. For example, this spring was arbitrarily named Spring S11 in the model. This information can be found in the description field, as seen here, and will be given in reports or can be displayed on the graphics screen as well. Let's review the information in the analysis and show how easy it is to delete parts of the model if desired. As shown previously, this is the pipeline information that can also be called out on the screen. All of the segment types are pipe, that is, there is no structural section or jacketed pipe. These are the pipe specs that contain the physical properties of the pipe. Here are the pipe dimensions, outer diameter, and wall thickness. All the material is A106 grade B. Then one can review the pressure and temperatures. The operating conditions in this model are 200 psi, 300 degrees F for all the piping. In ROHR2 there is no limit to the number of load cases in the analysis. So in this analysis we have dead load and operation as the load cases. However, we can have as many operating scenarios as necessary, and also any number of dynamic load cases. In some cases, it may be preferable to delete parts of the piping that was imported with the neutral file. For example, in this area, there are drains and vents that add little value to the model. In segment parameters, we can select this piping by either going to the pipe spec that contains that, the 3/4 inch pipe spec, or going to the dimensions and selecting the OD of the piping that we are interested in deleting. We can select several different pipe diameters, but in this case we will only select the 3/4 inch piping. We hit the select button and that piping is now read and selected. We hit the delete button. ROHR2 asks to confirm the deletion. We say yes, and the pipe is now deleted from the model. The model is still contiguous, and we can run the analysis again without this piping. After the analysis is done, if we change our mind, we can undo as many steps as necessary without losing previous information. Summarizing the content of this video, we demonstrated the opening of multiple PCF files in ROHR2. ROHR2 automatically connected the pieces into a coherent model. Information from the neutral files was retained, such as line numbers and support tags. Deleting unwanted piping is simple. We filtered the small bore drains and vents for selection and deletion. We checked the model's pipe sizes and operating conditions. Then we ran the analysis and showed the results. For more information, testimonials, or a program demo, visit us online or email us at rohr2@naumann.com. You know, sometimes it depends on how you look at something. Sometimes it doesn't. When it comes to saving time and money with ROHR2, it's a good thing. Thank you for watching.